Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 177 and 178. We are discussing construction of stability diagrams. We are set to take 6 examples. First example is over. This is metal oxygen system. Today we will take up this one. This is, as I already mentioned, that today we will take up copper sulfur oxygen system. So second is what? Today example second, copper sulfur right here. So start. System copper sulfur oxygen involving, good idea to write this explicitly, involving copper oxide, involving copper CO2S, CO2O, copper CuO, cross oxide, cupric oxide, then Cu2S, then Cus, then copper sulfate and oxysulfate. CuO, CuSO4, copper oxysulfate, all solids, all pure solids. 1, 2, 3, 4, 5, 6, 7. 7 pure solids, all pure solids, and obviously since sulfur and oxygen is there, we have a gas phase, and sulfur dioxide and the gas phase, and the gas phase containing PSO2, O2, etc. For example, okay? So this is the title of second example. 6 examples, one over. This is the second. Let us complete this second one. It will be pretty lengthy because there are a number of equilibrium. So start. So as I already mentioned you, how to start. To begin with, as before. By the way, I may give you an outline of what is going to come. See, this is finally will achieve. This diagram. This diagram will finally achieve. Okay. So this is the diagram that we will achieve. This diagram is yes, here you are. See, I'll keep on explaining. Before this, I give you actually a quick outline. What is this? Log PSO2 is plotted against log PO2. And before all, this diagram is drawn for a given temperature. T is fixed. I have said 1 degree of freedom already applied. With this diagram is drawn with 1 degree of freedom already applied in the form of temperature. So after this is fixed, then these are the variables. Here, this is variable, this is variable. So this will be discussed at length. So log PSO2 against log PO2. You see, this is the stability region for copper, and similarly for Cu2s, and similarly for Cus. Then you have get this Cu2O stability region. This is Cuo, and then you have this big region in the corner diagonally to copper is copper sulfate. Then you have this band here, it is oxysulfate stability domain. Copper oxide, copper sulfate means oxysulfate. And this one, the terminal one is CuO, okay, the nucleic oxide. So these are the stability region. I have given the caption is stability diagram for the system copper, sulfur, oxygen. Few things are to be noted here. It is better I tell you beforehand. Use this copper will be metal. The others are compounds, combined state of copper. This is pure metal. Usually copper, the metal will be at the bottom and left corner will occupy. This is normally true. Because there is some rationality behind this, because we have not yet increased the oxygen potential or neither the sulfur potential, so metal phase will be stable. As we increase the sulfur potential, see sulfides keep on emerging, Cu2s, and still higher sulfur potential Cus. And on the right hand side, if you keep on oxygen, increasing oxygen potential, you have the oxides. In the forms, first is the Cu2s, Cu2O lower oxide, then the higher oxide CuO, and then I tell you what that is important. So the diagonal means you are increasing sulfur dioxide and oxygen, both. The combined effect of when both are increasing, combined effect. When oxygen is increasing in this direction, in the x direction, and when sulfur potential in the form of SO2 increasing, so in the y direction, and the diagonal direction when both are increasing. So you'll get, it is no surprise that you will see sulfur sulfate, which contains sulfur and oxygen both. So that's why I have written here, usually the sulfate phase. This is not only for copper, actually you can take up vanadium also. You can take up other metals, okay, manganese also, okay, this nickel also. So usually the sulfate phase region is located diagonally to the metal phase, means copper. I have already said what copper is, what rather. I am coming back to this. Before copper is where? Usually the metal phase stability region is located at the bottom left corner, this place is for metal, and sulfate will be what is said here. Usually the sulfate phase region is located diagonally to the metal phase, diagonally to the metal. Why? To the metal, diagonally to the metal phase as the result of the combined effect of both PSO2 and PO2 increasing. So that's what this. And another thing is that some other thing I have said here. Note about this y-axis and x-axis. Note PSO2 on the y-axis is a measure of sulfur potential. While and PO2 on the x-axis is a measure of oxygen potential. Okay. See, PO2 is oxygen, and since SO2 contains oxygen, sulfur as well as oxygen as well as sulfur. Sulfur is the additional, so it is sulfur potential. It could be PS2 also. That is also directly sulfur potential. PSO2 also has sulfur. In fact, SO2 and O2 will generate a sulfur potential. So this is a measure of sulfur potential, means sulfur, you will have sulfides in this direction. And this is oxygen, PO2 directly is oxygen potential, so oxides here, and sulfate and oxysulfate, okay, in the corners, okay, particularly the sulfate in the corner, diagonal positions to the copper. So in the this what I should say, it is actually top right. This is bottom copper, bottom left. This is top right. Oxysulfate beneath it. Okay. So this is actually small band oxysulfate stability domain. What else I have said? I tell you, you will soon see 3 degrees of freedom, etc., etc. This I will explain when I say it. I will explain it. It is written here 1 degree of freedom already applied in the form of temperature. Before we started drawing this diagram with under the consideration that temperature is fixed. This is actually a way of applying the degrees of freedom. When you have 3 degrees of freedom, I said that it is not, then it should be a 3-dimensional diagram. But we prefer 2-dimensional. So temperature, if you fix one of them, for given temperature, if you draw the diagram, so 1 degree of freedom expanded. So remaining 2 degrees of freedom, yeah, I have written here. This is y-axis is the 2nd degree of freedom, log PSO2, or say PSO2 simply, and log PO2 is the 3rd degree of freedom, PO2. This actually I am going to write actually okay, in few lines. Okay, to begin with, as before means in all cases I started like this, as before. M max, maximum degree of freedom, is corresponds to C minus P minimum plus 2. What is this? C is what? Okay, C number of component is 3, copper, sulfur, oxygen. P minimum will be 2 plus 2. You may explain here. C is 3. How it is? Copper, sulfur, oxygen system. P minimum is what? What is the minimum number of phase? Minimum number of phase. One solid at least. One condensed phase, the stability region you see. One solid and accompanying gas phase. So one solid and gas phase are shown where? See, you don't see inside here so gas phase. On the axis, y-axis and x-axis, they are actually referring to the gas phase. So minimum is 2. It should be 2. Oh, sorry. It's 2. 1 solid and 1 gas phase. Gas phase will contains SO2 and O2. Okay, minimum. So you write here nicely 2 solid 2 to minima. I have substitute. What you get out of this? 3. When it is 3, then it should be 3-dimensional. But we want 2-dimensional. So what we do? Standard practice is what? Fix one of this and plot 2. Then 2 variables plotted can be accommodated in a 2-dimensional diagram, which we actually prefer. So which we want to have the presentation. Fix one is what? Which in the form of what you are fixing here? Tell me the temperature. So let us write this. What you have fixed? Fix one. This is what? T is 1000 Kelvin. I have given here is 1000 Kelvin. Say that means it can be 900 Kelvin, can be 800 Kelvin. Fix and what other attributes to the fixed one is what? that you say, oh, that is the degree of freedom. Out of 3 degrees of freedom, 1 you are so 1 degree of freedom already means you have to understand before you have started drawing the stability diagram already at the start, at the very beginning, under the consideration of this applied degree of freedom. In each case, you see in phase diagram also I said the diagram is done for P is 1 atmosphere, means there 1 degree of freedom is already applied. And the remaining degrees of freedom we will get from the stability, from the resulting diagram, and depending upon the number of phases, whether we consider the region in surface or domain, or we consider a line, curve, and or we consider a point. So depends actually, that will be. So 1 degree of freedom already applied. I use the, so don't, this will be is 1000 K. Already applied. So it's better I don't come down here, already applied. Applied. Plot 2, which you will plot here? Plot 2. Why? What is the purpose? For actually, I am just using is 1000 Kelvin. I have showed here. Say I have written here. So plot 2 for a 2-dimensional plot. For 2-dimensional plot. 2D. 2-dimensional plot. You plot 2. So it is very suitable. So, and you can consider this is actually, so 2 degrees of freedom, 1 already, 2 degrees of freedom remaining, 2 degrees of freedom remaining. What and what we have considered these 2 degrees of freedom as log PSO2 the variable and log PO2 the variable. Log PSO2 and log PO2. It could be very easily PSO2 and PO2, not log, just ordinary. So, but the reason we use log, I told you all that to generate straight line behavior, straight line presentation, straight line representation of the equilibrium. So log is necessary. This I say. Otherwise, it will be non-linear. Okay, good. So this is okay. What else? By the way, about there is no compulsion about considering PSO2 and PO2. It could be what? PS2 and PO2. No problem. Or say PSO2 and PS2. No problem. Any two. Okay. They are actually interrelated. Where there is SO2 and O2, there is through equilibrium S2 also, the gas, S2, sulfur gas. Through the equilibrium, S2 plus O2, half O2 is SO2. I am sorry, half S2 plus O2 is SO2. So always, in the sulfur trioxide, SO3 is also present. You can consider that. But we have considered some simple thing, no problem. Also, but for concept, you should note that. What you should note that yes, note and so what I said, PSO2 PS2 and PO2 or PSO2 and PS2 etc. could be alternatively plotted. So careful. So about this is a preparatory to the diagram. So after this, what is next? Find out the number of metastable. This is something new thing. We have not considered this in the case of metal oxygen system. That was very simple, but here actually you will understand that there are many metastable lines, and I will show you one here. Okay, when I will start. For example, copper sulfate, copper CO2s and CO2 I will discuss. But altogether, how many metastable lines are there? This I'll actually explain you. This you should know, and you will easily find out them that there are many metastable combinations. Okay. So this is something okay, new maybe. So you give a line here, border. Start here. Next, shall I give here? Where? From where? Here. From here. You start. You start here. Next. Find out the number of metastable equilibria involving what and what? Involving first is what? Single solid and gas phase. Single solid and gas phase. What is this? Single solid and gas phase. The total number of solid phase singly present. Solid phases, the total number of domains where or in which solids singly present. You see how many? You can clearly count. Copper, CO2s, CUS, singly present. CO2O, CO, 1, 2, 3, 4, 5, 6, 7, copper sulfate, oxysulfate. 7 singly present. And what should be the number that you find? Then you will see all singly present solids are shown in the diagram. But later on you will see, I will explain the next case. Single solid and gas phase. The total number is what? How to get total number expected is what? Ideally expected. A single solid and the gas phase. Sorry, I should have not missed this. And the gas phase, write this. And the gas phase out of 7 available solids. Out of 7 available solids. How many solids available? 1, 2, 3, 4, 5, 6, 7. How many is seen in the diagram? See, 7. So means there is no metastability here. Okay, that means all are featuring here, showing here. So this is the purpose. So out of 7 available solids. Out of 7 available solids. 7 available and 7 are 7 domain we have seen. So what is how you get this? Total number is is 7C1. Just 1 out of 7. How many combinations? 7C1. is what? Factor is 7. C1 is, everyone knows, it is 7. So that means all 7 are shown. This is actually, this should be the number that is available, and available means that should be presented, and we are seeing that the 7 are presented. So we can write that solids, since only the is this open, so why it is 7? 7C1 is 7. Since all 7 since all 7 wait. Since all 7 solid phases are singly shown in figure 2. This is figure 2, this number is figure 2. In figure 2, each single over a 2-dimension area, or area means 2-dimension or domain. Each over a 2-dimensional area area, or you may call it domain. The number of metastable single phases is 0. So this is 7, it should be 7. Out of 7, taking 1 at a time, so 7 possibilities, and all are showing there. Now you will understand this, why this exercise is important. In case of 2-phase, you will see the possible number and actual number will not match, will not be in agreement. The balance, the difference will be metastable possibilities. If all will follow soon, understand. Second possibility is, I have said, involving a single solid and the gas phase. A single solid and the gas phase, or you give this a colon, understand, a single solid and the gas phase. This is as if involving this first case. The second case is what? Involving two coexisting solids and the gas phase. The total number is tell me, it is what? 2 at a time. Out of 7, 2 at a time. Like say copper Cu2O, Cu2O, Cu2S, or say Cu2O, Cu2O, Cu2S, and so on and so forth. What is possibility? 7C2 combination is what? Factorial 7 over factorial 2 factorial 5. which is nothing but 7 times 6 by 2, which is nothing but 21. So 21 possibilities, mathematically combinations. But how many combinations? Two phases coexisting. What I give you example. So it is copper sulfide. This line, along this line, they present along a line, curve, line, one dimension. So copper sulfide, this line. Similar, this is what who are present along this line? Cu2s and Cus. Who are present along this line, vertical line, copper Cu2O. Similarly, this inclined line, Cu2O and copper sulfate, so on and so forth. But 21, but how many? How many are there? So count, let us count the number of lines. Not domain. Lines is better. 1, 2, 3, okay, 4, 5, 6, 7, 8, 9, 10, 11. So out of 21, 11 are showing here. In this stability diagram means stable lines. So remaining 10, the balance 10 metastable lines. 10 metastable and not shown in the diagram. You cannot show them. You might ask me, sir, what are they? What are the possible? Yes. See, along this line, who pay? Cu2s. But why is Cu and Cus meeting? Which line? Cu and Cus, no line. Separated. Cus and Cu separated by the band of Cu2s. Cu and Cus not meeting. So that is a metastable combination. And the gas phase, obviously. Similarly, you may ask, so why is the Cu and CuSO4 meeting? No. Cu here or CuSO4 right there. CuSO4 with CuSO4 who are meeting? Cu2s through this line, Cus, and through this line, Cus, this one, Cu2O. Okay, and of course oxysulfate, but not copper. So these are the metastable combinations. So let us note down this. So this 11, since you count 11, okay, since only 11 two phase, which are the two phase solids. Two phase means which are both solids. Two phase solids. Two phase coexistence. Are shown in figure 2. Figure 2 is represented by this. You add this one, each represented by what? Two solids, and of course the gas phase represented by what? A line. This line or lines. Okay, by line. By a line. Line means what? This is one dimension. Good. The number of, since so 21 should be ideally available. How many are actually found? 11. So 10 metastable combination. So let us write this. So shown in the number of two solid metastable coexistence. Two solid metastable coexistence.
লেকচারটা একটুখানি কেটে গেছে সামান্য।
Who is actually writing this? It's okay, no problem. It's okay, sir. Otherwise,
Otherwise, okay.
this one bottom is
Okay,
okay.
okay.
Two solid, okay, I will be careful, more careful. Two solid metastable coexistence. Two solid metastable. You know, underline metastable. Two solid coexistence. Two solid. Actually, you change this. Better you write number of metastable. Write metastable first. Metastable. Underline maybe. Two solid coexistence. Two solid coexistence is what? How many? How many are metastable? How many? 21 ideally minus 11 actually in the stability diagram. So 10. Example I have already given. So you may write that 10 which are there. E.g. for example, who are like say I said copper Cu Cus. They don't coexist. Cu2s coexist along this line, and Cu2s Cus coexist along this line, but not Cu2s. That can be made to coexist. That is very different problem and very challenging problem, very nice problem. At what temperature they will coexist? So then in that case you have to change the temperature. For this temperature, no. Eg, okay, don't worry about this. So Eg 10. Eg what? Example, tell me. Cu Cu2s. Impossible. Impossible means in this have not coexisted, are not together. Who else? Cu and Cuo. Remember Cu2O, Cu is with Cu2O along this line, vertical line BC, and Cu2O with Cuo along this vertical line JM, but not Cu with Cuo. So Cu, and also you can say argo CuSO4. And there are how many? You can keep on writing. Okay, E.g. So since I started this bracket, you complete the bracket, close the bracket. This is. So this is okay. Second case, I have started here involving first case, second case, third case. We have not entered into the construction of the diagram yet. Just giving some queries we are addressing, some preparatory thinking and or explanations. Okay, third we'll soon take up the construction. Third is what? Third was, tell me similarly, it is one solid, two coexisting solid, and of course the gas phase. Three. Now it will be three. Three coexisting solids. And the gas phase. In the gas phase, the total number is what? How many? Ideally, the 3 together. Out of 7, 3 together. Answer is 7C3. 3 like say Cu Cu2O Cuo. Cu Cu2O Cu2s. Cu Cu2O Cus. Cu Cu2O copper sulfate CuSO4. Or next start Cu Cuo Cu2s, and see you can count. But it is easy to get from 7C3 combination relation. The total number total number is 7C3. 7C3, 3 at a time. Out of 7, factorial 7, factorial 3, factorial 4, which is nothing but 7 times 6 times 5, so 5, 3, times 2, which is nothing but 35. 35 ideally possible. Again, since, but how many we are seeing? How many? 3 solid together. They are together like where? You see, this was at over a domain, 2-dimensional single solid, 2 solid over a line, and 3 solid will be a point. So where 3 solids meet? Example B, sir. B. Which 3 solids? Copper, sir. Cu2s and Cu2. So how many these points are called triple points? So let us take a look how many such points are there. Should be ideally 35 such points. But how many? 1 triple point, second, third, fourth, fifth. Only 5. Only 5 triple points and 3 coexisting solids. So remaining 35 minus 5, 30 metastable and not shown in the diagram. They are metastable triple points. So let us write this out. The total number is okay already over. Since only 5, as you counted, 5 3-phase solids, 3-phase coexistence, and in the form of solids, 3 solids actually, 3 solids, 3-phase coexistence. These are all solids. The 3 coexistence are shown. Only 5 you have counted are found, are shown in figure 2. Are shown in figure 2. Figure 2 is represented by a point, as I have showed, point, triple point, by a point which is known as 0 dimension. So line was 1 dimension, now it is line previously it is 0 dimension, as it should be. Point is 0 dimension, and this is also called, this point is called triple point. The popular term triple point. The number of metastable 3-phase coexistence, how many? The number of metastable 3 solid coexistence. Coexistence is how many? Is what? Tell me. 35 ideally minus 5 points. 5 actually is 30. As big as 30 metastable. 5 only stable. You will ask me, sir, which are sir 5? I can tell, I already told you perhaps, okay? Cu2s, then I said Cu2s and Cus, where they meet? They don't meet. There is a point. Can you show them meeting at a point called triple point? No. Cu2s, Cus4, where? Cus, this point for example, this is Cu2s, Cu2. Cu2 and Cus4, where? None. Suppose the involving Cu4 is what? This point. This point is what? Cu4, Cu2O, Cu2s. Common point. Here also another Cu2SO4 involvement. Cu2SO4, Cus, Cu2s. Repeat. CuSO4, CuSO4, CuS, CO2S. Similarly, here CuSO4, CO, CuSO4 oxysulfate and CO2. So you see, okay. So what I said, they are present, but I said you don't have CO2S, CuSO4. These three phase coexistence, togetherness, no, absent. Or CO2 or CuSO4 absent. Cu oxysulfate, copper sulfate absent. Absent. 30 such absentees. Impossibilities. Under the condition of temperature is 1000 Kelvin. Okay, very good. So 30, but 5 stable action is 30. So these are the preparatory discussions. As example, it is good idea to give example, as I have already told you. CO2S and CUS not possible, not shown, not found. CO2O, CO likewise not found. CO2S, CuSO4, etc. Because I cannot write 30 here, okay, I don't need also. So this part is over, okay. So people, next take up the construction of the diagram. How we got this diagram, okay. Construction of the diagram. Diagram is which is figure 2, okay, of the diagram. D may be capital. Construction of the diagram. Okay, start. A first equilibrium. Equilibrium what? Copper, CO2S, okay. Copper, CO2S and the gas phase. Remember, the answer to this question is here, where you write along the line CO2S coexist below the line Cu, above the line CO2S. This is all in nutshell, okay, about this equilibrium, okay. This but what is the slope? I have given the slope here in the figure. I forgot to tell you. These are the slopes. One is the slope. Here it is 3/2. Here it is minus. Oh yes, right. -3. Here it is. This is vertical, infinity. So this is her -3/4. So on, slopes will generate, will derive, will find out. So these are the, then you can draw. Of course, slope intercepts are also there. So that will see actually which thermodynamic data corresponds to the slope. We'll see this. Because this is okay. And what I tell you beforehand. So I will have to take up this CO2S and I will construct the line AB. Okay. Then I will take up which one? Obviously, next one is CO2O. Second one B. That will be shown as a vertical line. This will establish why it is vertical line. And third, by the way, CO2S I will show that it has a slope of 1. That will show. CO2O is a vertical line. That will show. Will show this. Third is obviously CO2S, CO2O. Then obvious the remaining one is CO2S and CO2O. Will be shown by which line? BD. Again what? With a slope of 3/2. Means it is slightly steeper than 1, greater than 1. 3/2 is greater than 1, slightly steeper. This again we will establish why the slope is 3/2. This is our job in fact. Then we will be able to draw the diagram. We have drawn the diagram as if ourselves, not by any software. Okay, good. With understanding you are drawing. The software does the drawing for you and you don't have any idea how they are drawn or what they signify. So very much difference. Okay, you may take help of software for complicated diagrams. That is, but once you have understood the concept, ideas, significance, interpretations, so on. So I tell you what, when these are drawn, again, beforehand I tell you, I will show you just in nutshell. I tell you, consider only these three lines. Don't forget, ignore. Don't consider the other lines. Only the three lines. I repeat, AB for copper sulfide coexistence, and the gas phase always. Okay, and BC copper oxide coexistence, and BD copper sulfide copper oxide coexistence. The question now, the metastable concept that I actually gave you, concept that I discussed last class elaborately, thoroughly, this comes here. That metastable consideration. This is something new. This is a different story. Here, okay, this is actually okay. I've explained this. That metastable. Remember, 6 segments alternately stable, metastable, stable, metastable. I said, on one of these three combinations, three arrangements. Three combinations is a metastable configuration or stable combination, and the remaining three metastable. It cannot be otherwise. Two choices, because they are alternate. Stable, metastable, stable. This I said. So you could ask me, so why it is stopped? How to start this discussion, this argument? Why is metastable? Because you might argue, sir, why it is stopped here? Why it has not gone further? And others say here C prime up to this point, C prime. Then BC prime is the stable line instead of BC is the stable line. You could argue. Yes, a good argument. Then I explained you last class, totally discussed, fully discussed, that why it can be shown that metastable, here also similarly, AB, if you extend here, it is BA here, BA prime. Similarly, BD, you extend this side, it will be D prime. So why not BD prime? Why not BA prime? Why not BC prime are drawn, are accepted, and which you have considered here are rejected? Why didn't this happen? Answer is, alternately they are present. So 3 will be stable and 3 will be metastable. There are two options only. These three. This. So 1, 2, 3, 4, 5, 6. 1, 3, 5. Either if it is stable, then 2, 4, 6 will be metastable. On the other hand, if 1, 3, 5 is metastable, then 2, 4, 6 will be stable. No other. So only two options. So this I said. Then how to find which is stable combination and which is metastable combination? Unstable. Metastable or unstable. Okay. Metastable combination is what? Which one will be? I said stable lines are mutually compatible, thermodynamically compatible, and metastable are incompatible, and discard. So here what I will show you here. Okay. Let me draw these three lines first, as you see. Then I will extend this dotted line metastable. Then I will show you that why these three lines in the current form are retained in the diagram, while this dotted are removed from the diagram. Copper sulfide gas phase, you start here. Copper sulfide, what is the reaction? Cu2s plus O2, which is right here. Copper sulfide solid plus O2 gas is 2Cu solid plus SO2 gas. Okay, call it equation. Will you give a name? Yes, good. Equation 1. So A1. Okay, equation 1. So you start from delta G01 it is a good idea. I give a star mark here, and let us go to the top. Let us go to the top. Remove these lines, beginning lines. Delta G0 1 is A plus BT. A plus BT, where A and B known quantity from data book. Known A plus BT is known, okay, is what? Minus RT ln KT, okay, that T is the temperature that you have fixed, okay, A plus BT. Now if you have solved this, A and B are known, R is known, T is known, T is the temperature that you have set, so KT will be found. So KT is known. I am writing this means KT is found. Okay, is what KT expression you write nicely, right? ACU solid square times PSO2 over SU2S solid times PO2. Now these being one, pure solids, both being one, what you have? PSO2 over PO2. PO2, okay. Just remove few lines further so that you get some space here. Okay, so we have, okay, very good. So we got some space. Or you keep on doing this. Okay, move on with this. Then take log. As you see, log is will be plotted. Or can I write this? Or I'm continuing. Log PSO2 is what? Log PO2 plus log KT. KT thermal equilibrium constant log KT. A linear equation, you are sure. Linear equation. So what you will do? Hence, it is straight line equation. Y is M is 1, X, log PO2 is the X, Y is the log PO2, Y is M, X, M is 1 plus C. C is the constant intercept. Okay, hence slope 1, M is 1 means slope 1. So hence log PSO2 versus log PO2. Plot will be a straight line. Will be a straight line with the slope of slope of 1. The slope of 1, okay, represented by my line 1, my line what? Which line? You see AB, where copper and copper sulfide coexist, this equilibrium, equilibrium 1, reaction 1. So AB represented by AB, by line AB, Note what? So along the line, note along the line, who are present? Always along the line, above the line, below the line. I'm sorry, above the line and below the line. Along the line, both. That is represent. So copper sulfide and copper oxide both present, coexist. Above the line, 1 copper sulfide. As you see, here copper sulfide. Why? Because SO2 is increasing. If SO2 increases, my reaction moves towards this, copper sulfide will be stable. And below the line means PSO2 decreasing. So if it is decreasing, okay, this way it will move and copper will be stable. Okay, or you may, okay, this is fine. So along the line AB, both Cu solid and Cu2s solid along with the gas phase, always present. So you mentioned this, along two solids and gas phase, along with the gas phase which contains, you may consider this SO2O2, comprised of SO2O2, coexist as stable or equilibrium. Stability diagram means equilibrium diagram. Phase diagram is stability diagram or equilibrium diagram. So stable or equilibrium phases. Over, okay. Above the line, now above the line, AB, above the line AB, Cu2s plus the gas phase, always plus the gas phase, that's I'm writing, plus the gas phase is stable, and below the line, again we mention line AB, below the line, or that line AB implied copper solid and plus the gas phase, below the line copper plus the gas phase is stable. So we have completed case A. This is over. Means line AB is over. Let me first draw 3 lines, then I will just take up that old issue, stable, metastable. Why extension of these lines, here or here vertically upward or here down are removed from the diagram because they are metastable extension. This part I will take up in this case just to show the applications of that stable metastable consideration. So that I will take up. So let me first draw AB is over BC and BD, these 3 lines, then I will show you. Okay. So let me remove this. Okay. Start. Second case. A is over. B is what equilibrium? Copper, which I am considering? Copper oxide means cuprous oxide and gas phase. Second one, what is the reaction that you consider? What is the reaction? Very easy reaction, you know. So you have oxygen on the left hand side always. Cu solid plus O2 gas gives you what? Cu2 solid. No problem. Make it 2Cu and make it half O2. That's it. Call it equation what? This is 1, then this must be 2. So write in the same manner, delta G02, remove this. Delta G02 is what? A plus Bt again. It is A prime plus B prime to me. It should change. Previously it was A plus Bt, now it is A prime plus B prime T. Again A prime B prime known. But what I tell you, yeah, I am using A plus, you understand, no problem. Is again unnecessary. If I give prime, then 11 cases are coming. So you have to give 11 prime or 10 prime. So it's not very practical. So I write is A plus Bt form. Always I write A plus Bt. You understand the corresponding A and corresponding B. For this reaction, A and B will be different from the A and B of this reaction, obviously. Okay, so because A refers to delta H0 and B refers to minus delta H0. So very good, A plus Bt, or simply A plus Bt, you write here, or this A plus Bt, or simply if you have no confusion, no, or simply A plus Bt. This I will use always, okay? Instead of giving A plus Bt is what? Minus RTLN KT, as before, as I have already explained. This you know everything again. See, you know T, remember T is known, 1000 Kelvin, that we have considered. So you can get K. R is known, KT is, tick mark means known, is what? KT expression, right? Nicely. ACU2O solid over, for this reaction, ACU squared solid over times PO2 power half. Again, what simplification will make here? This is 1 pure solids, this is pure solid 1, or you get what? Or you write nicely, or, so this is a constant, KT is a constant, KT is a constant at the given temperature, KT is a fixed quantity, fixed number, so KT is a constant, so PO2, 1 by PO2 is constant, means PO2 is constant, so PO2 is constant, or what is important for you, or log PO2, because since you are using log PO2 is also is constant. So this is your equation. Last time equation was what? This one. This time equation is this, log PO2 is constant. So how will you present it? X is constant, means it will be parallel to, X is constant is what? Parallel to Y. Okay, parallel to Y is actually X is constant, so it will be a vertical line. It will be a vertical line. So we will write this. It is constant, vertical line. Vertical line. What line? You see, tell me. BC. Vertical line BC. Good. So this. So it's hence along the line BC, you write, mention this, hence along the line and above or below or on the right, on the left. That's good, okay? So here the consideration will be applicable, the consideration that you will make on the right, on the left, because it's a vertical line, so it cannot be above, below. Inclined line above, below, or on the right, on the left, possible, both possible. So hence you get the consistent answer, no problem. Hence, along the line BC, remember this line BC. Hence, along the line BC, both CUS and CU2O coexist. Both coexist as stable phases. As stable phases. As stable phases. That's a time.
1 hour 10 minutes gone. 50 minutes left.
50 minutes.
50.
अच्छा. Okay. It's okay. So it's okay. So coexist as, so both solid and CU2 coexist as stable phases. As stable phases, you may write or coexist, good enough. They will coexist as stable phases. As stable phases, okay? Stable phases. So on the left of the line, which stable? On the left, copper. Why? Because low oxygen decreases. So if you on the right, CU2O alone, along the line both, CU2O both. On the right of the line CU2O, because why? Oxygen has actually crossed this limit, has been increased beyond this value. As we increase PO2, oxygen, who will be stable phase? Where it is? I'm sorry. Where I am here. If oxygen is increased, who will be stable? CO2. So no surprise, CO2 will be stable on the right hand side. And if oxygen is less, then it will be moved to the left, and copper will be stable. So on the left of the line, copper solid, and on the right of the line, copper solid alone. When I write alone, copper solid, it is not copper solid alone, but always the gas phase plus the gas phase. So you should note this point. So I am not writing this copper solid. The important thing I am writing copper solid alone, and on the right, copper oxide alone. Are stable phases. Okay. So two lines are drawn. Which two lines? Because AB drawn, BC drawn. And next I will take up BD. Obviously, AB, BC, BD. BD involving what and what? So I repeat, AB, CU2S. BC, CU2O. So what remains? The third. Obvious arrangement is CU2S and CU2. Their coexistence is given by BD, that will take up. So this is where we are remove this. Not bad idea. Remove this. Stop. C. You write CU2S like this. CU2S, CU2O, gas phase. Write the equilibrium. Okay, you see. So how we write CU2S solid plus half O2. Also, I'll give you O2 later. CO2 plus is what? What you have? CO2O. CO2O solid plus SO2, and then balance it. You do the balance. CO2, 2CO balanced. S balanced. Balanced. What is how many O2 here? O2, 2O and 3O. 2O and 3O means it will be 3 by 2. 3O. 3 by 2 O2 is 3O. So it is 3 by 2 O2. This okay. Quality equation 3. You write here. This is 1. This is 2. So C actually case C and third equation. So it is easy to follow this. Okay. How to start? In the same way. Delta G0. Start. Take up. Delta G0. Little faster now. Delta G0 3. As I have already told you, A plus BT. I'll just write A plus BT. A and B is known. Is what? Minus RT ln KT. Okay. RT ln KT, which gives you KT is known. What it is equals to activity of CO2O times PSO2 over activity of CO2S times PO2 power 3 by 2. Sorry. 3 by 2. Like this. Under equilibrium, right actually, we are considering the equilibrium relation only. We are considering equilibrium relations only. So anyway, what is this activity? Solid, pure solid 1. So what you are getting here? Yes, PO2 or take log PSO2 is what? Take this 3 by 2 log PO2 plus log KT. Again equation of linear equation. You should note that, right? A linear equation. Linear equation. So what you should comment here? Let us comment this. Hence, what you will get? What is the slope? Log PSO2 versus log PO2 versus log PO2 is 3 by 2 slope. And what slope you got? Which line this is? This is which line? BD. As we already described that CO2 is CO2, BD. They meet along BD. And what is the slope? 3 by 2. What is the slope? 3 by 2. Hence, the log PSO2 versus log PO2 plot is a straight line, will be a straight line with the slope of 3 by 2. The slope of 3 by 2 with the slope of 3 by 2 represented by which line? BD. My line BD. Line BD. Here BD is okay. Very easy. Okay. Note as before. So as before, the comment along the line, above the line, below the line. Note. A good idea. I give a star here. Continue on the top, na? Is better. better the first. These are all used up, discussed, completed. Start here. Follow. Yes, okay. Hence the comment, hence the log value will be number 3. So note as before. Along the line, which line? As we are discussing currently, BD is a BD. Along the line BD, both CO2s solid and CO2O solid coexist as stable phases, okay, as stable equilibrium phases, as stable phases, as stable equilibrium phases, okay, redundant, stable phases means equilibrium phases. Equilibrium, okay, so stable phases, very good, as stable phases, equilibrium phases, above the line and below the line. Above the line BD, which is stable, you can get from this. Above the line is PSO2 increasing, PSO2 increasing. If PSO2 increase, which way? Which will be stable? CO2s. And no surprise, CO2s the stability here above the line. And below the line opposite, below the line CO2O. So above the line BD, CO2s solid alone. Acha, one thing I tell you, here writing CO2s solid alone will be stable. But this is, remember always, I am repeating and repeating. Okay, that is not alone as solid alone plus the gas phase. Similarly here, CO2s solid and CO2O solid coexist. As two solids, these two coexist plus the gas phase given on the y-axis and x-axis, okay, on the axis. Okay, so CO2s alone, as I was writing, CO2s alone, and below the line BD, who will present, tell me, below the line CO2s below the line CO2O solid, above the line CO2s and below the line CO2O alone are stable phases. Stable phases. Remove these lines. Some important aspect is coming now, just now, because 3 lines I have drawn, and you may expect a triple point now. Very easy, triple point, and let us write down a few lines about the triple. Mention that triple point is a good issue. Means what? Where 3 phases are present, 3 lines meet, or 3 phases coexist. 3 solid phases, 3 solid plus the gas phase. So which is that? B. AB line we have drawn, BC line we have drawn, BD line just now we have completed. So they meet at point B. This is the triple point. This is a triple. Several triple points are there. B is there here. Later on D you will discuss. E, H, J. 5 you have seen. You already noted that. So 1 is actually we are coming across just now. So where 3 solid, which 3 solid meet? CO2s, CO2O, CO. Common point. So this we should mention. Okay. So that right note B is the meeting point of lines. Mention the lines, 3 lines, E, A, B, D, B, C. Write that nicely. A, B, B, C, and of lines A, B, B, C, and B, D. B is known as a triple point. Triple point, note as before. Okay, no, triple point where 3 solid phases, triple means 3 lines, 3 solid, 3 solid phases. Where 3 solid phases, copper, CO2s, CO2O. These 3 solid phases, and of course the gas phase. So you will always note that even if I forget, okay, CO, CO2s, CO2, or others, okay, very good. Exist, coexist. These 3 coexist. This is the message from these diagrams. Try to contrast and compare one solid phase and the gas phase, accompanying gas phase. How will you represent it? Over a domain, or region, over a surface. 2 solids. See, so that is 2 dimension there. That is 2 dimension. It's like copper, 2 dimension, over 2 dimension. 2 phases together along a line, 1 dimension. 3 phases together at a point, 0 dimension. This is the trend. So try to coexist, okay, along with the gas phase. Mention that along with the gas phase, comprised of PSO2, O2, as you have considered. Okay, good. You give a box here. So 5 triple points are there. We will actually box 5 times. First, this is the first one. Means B, point B. Okay, now I take up, before I take up where C, where is C is over. D I will take up. The fourth interval I will take up what? I will take up maybe CO2s, COS, maybe this line. Next, this line, and still next CO2s and COSO4 means this line, ED, and then COS and COSO4, EF. Then again second triple point, another triple point, E will come. This will go on and go on, okay, until 5 all lines are addressed and all triple points are addressed. This is the idea. So the whole stability diagram is explained, addressed, and discussed fully. Over. So, but one thing I will, before I move to the D, let me explain you one thing. That is something to do with what we discussed regarding stable and metastable. 6 segments, stable, metastable, alternate, 6 segments around triple point, those concepts. Metastable will be out. Finally, stable lines will be retained. As you see here, stable ones, metastables are where? That point I am taking up here to give you consistency in ideas, okay? To consistency in applications. Okay, like this. Okay, so this I will discuss now. So you please follow me. This will be interesting, so that if you have any confusion, then that will be over. Suppose I am showing you. I'll later on remove you. Okay, or maybe should I? Yeah. Okay. Here. Okay. Acha, I am considering this one. Okay. I am drawing you ABC. Acha, I am drawing you. Separate it. This segment, this triple point, I am actually presenting here and showing the metastable lines. You follow me. Here only stable lines are shown. And what is the rationale behind retaining the stable lines only? Removing the metastable lines are given here. Already you know, but you just compare your last day's notes today. ABC. I am drawing, see, ABC. So what is the drawing like? This. So what is this is A. This is your, what is this called? This is your B, and vertical C, and this goes to D. This is reproduced for discussion. Stable metastable, for stable metastable discussion, for stable metastable discrimination. Will discriminate. I am giving the answer. This will be stable, but argue against it. Okay, what? You just first extend this. You do not know why it should stop here. It can be go on. Dotted I have given for the timing on. You know what it is? If it is A, it is B, then it will be other side of A. Call it A prime. Actually, B A prime will be metastable. Why? That is the main question. Why B A prime is not stable and B A is not metastable? Why not? Similarly here, B C, if you extend this, B C prime. Since last day I discussed at length, I will not take much time, but you will appreciate if I give an outline here. Same logic, same everything, just like repeating BD prime. So 6 segments around the triple point B, 1, 2, 3, 4, 5, 6, and as a rule, 1, 3, 5 or 2, 4, 6. One will be stable arrangement, another will be metastable arrangement. So how do you distinguish them? Stable combination will be mutually consistent, compatible. They are compatible. So what is this? You tell me. I am showing you one by one. Okay. So this, what is this line? What is the line? See, tell me what is this line? This is above the this one, na? This one. Above the line what? Above the line. First one by one. AB below copper. AB below copper here. Right, copper. See, AB below copper. These are discussed. This is already discussed. And above CO2s. Just I am repeating. Since you don't know yet whether this is stable or BA dash this is stable, so you actually extend a little bit more for clarity. A dash here. So here also similarly CO2s below, above and below, deal right nicely, so that you understand yourself. CO2s above below, same you have to do. Okay, there will be an assignment regarding, so try to understand. CO1 is over. Next you take up the vertical one. Left hand side CO, right hand side CO2. So right here CU, and right hand side CO2. Not only here, This dotted one also same deal, because you do not know which is this is stable or that is stable. You don't know. So Cu2O, no problem. 2 down. Third one is about this line, and this line little bit extend this so that it is free from this crowding. Okay, from this place. Okay, here this side also will you. Yes, that is good. What is this line, by the way? This is AB, BD prime. Oh, this is D. I forgot to write this. This is D. Remember, this is D. This is D. BD, and the extension is BD prime. Again, tell me what is above, below BD. Above is Cu2s, below is Cu2O. So write that. Above is Cu2s. I'm writing first. Cu2s. This is D, and below Cu2O. Here same. You don't know. Hopefully, you just see the bottom line is okay. Bottom line is okay. Anyway. Cu2, so above Cu2s, below Cu2, since this is, you don't know, these are the same, because what is that? Cu2s above, below. This is your D prime. Now, as if you don't know, you mix up yourself. Yeah, I am not sure which is stable, metastable. So you try one by one. As I said, every other is stable and every other is metastable. So suppose you hook up on the correct 3. So which is actually showing here. Suppose you consider A, B, B, C and B, D. Suppose you are trying. Unknowingly, uncertainly, you trying, checking, examining if it is correct. You consider A, B, B, C, B, D are correct combinations. These 3 lines. What is that? They are compatible. They are in good agreement. Let us see if they are, according to this BA line, what it says? It says to the right, this domain is stability for copper. And what is the next? Next, we have pretended that it is stable line. These are stable. So this stable line says this is stability for Cu, and this line is also saying the same things. This zone is stability for copper. They're compatible. Agreement, harmony. Try. This and this, try. This says this is Cu2O stable. And this says, oh yes, Cu2O below is this. Cu2 stable. Cu2 stable. Cu2O stable. Cu2O stable. Compatible. Agreement. And take up the last one. You don't have to. One, if you find one actually compatible, one pair of lines, means all 3 pairs will be, these 3 pairs, this pair, or this pair, will be stable. But still, for your curiosity, check here. This and this. This line says this is the stability field for Cu2s, and this says this field is stability for Cu2s. So you are sure these AB, BC, BD are stable lines which you have drawn here. Now you have to prove that the dotted lines make an unstable, metastable configuration, metastable arrangement. Let us see. And to show that they are mutually incompatible, there is a clash, disharmony, disagreement. How? Follow me. Okay? See. Take up this BT prime, and next is what? BA prime. These 2 you are taking. See if they are compatible. BD prime says this is stability domain for Cu2O, and this line says this is stability domain for Cu. This says this is stability for Cu, and this says this is stability for Cu2O. Cu2O, Cu class means metastable. And once these two means this alternately, so this will be also metastable under the metastable arrangement. So try this and this. This space, according to this BC prime, to the right CO2, this space is CO2 stability, and according to this space the same, right? To the left CO2s class metastable components, segments, and last is this and this. You try this also to satisfy your curiosity and your queries. Okay, see, this says here above is CO2s, and it says next to it CO2s Cu class. CO2s, it says CO2s is stable, it says Cu stable class. So what you will do, you will discard this dotted line and draw this, discard these lines, that I will discard at the end. Okay, I have already discarded here, and this will be discard the dotted lines for remaining lines, 3 lines, the stable lines which you have drawn here. Another viewpoint I told you, that is as in case you have not followed today, I have seen this diagram is we are discussing and relatively clear diagram, so it may help. Another thing I tell you, thermodynamically another way. At a given point in the diagram, given point, given state, you try to find activity according to two consecutive lines. One will be stable, another will be metastable, and see which one gives rise to a lower activity, means lower free energy. Then that line which corresponds to a lower activity, that line will be stable line. This is another comprehensive thing, and this further reinforces your confidence, knowledge. So I'm trying consecutive 2 lines. So this is the point you are thinking. You are considering too much. Okay, this point. Try to get consecutive 2. So all 6 you have drawn 2. Achha, tell me, according to this point, what is the activity of copper? According to this says what? Activity. This says what shall I write? I am writing activity of copper is how much? It says below it's copper stable. Copper stable means activity of copper, pure solid copper stable. And above CO2s, forget. Consider copper. Activity of copper is stable, means activity of copper is how much? Physically present, solid, copper solid, activity, copper solid is present here. Here means below, means here, up to, below and to the right, means here, up to here, this point, covering this point. So activity of copper is 1 according to this dotted line. And you ask the same question to this next consecutive, this line. You ask it. So what is the activity according to you? Active copper, I'm showing you, this is 1 according to, I'm giving you arrow, you understand? It is better I write here. It is good, better. This dotted line says activity of copper is 1. Copper solid is 1 here. And this line says what? It says it is copper oxide stability. Means activity of copper oxide is 1. And what is the activity of copper? It is absent here, means physically absent, means less than 1. Copper is at 1 where? Here. This side, and along the line both are present, and both are with 1 activity, unit activity. The question is this side 1, but we are not interested. This is to the right hand side. So you ask, what is activity of copper according to this curve? According to this curve. Your question will be like this, according to the, and the activity resulting, a lower activity resulting from the curve, from from one of the two curves will be okay. Lower activity will correspond to the stable curve, and the one which is higher, greater activity, metastable. See here. So at this point, same point, according to this line, this domain is activity of copper is less than 1, which is absent. Copper oxide is present. Copper oxide activity is 1. Okay. Or on the line also, activity of copper and copper oxide, CO2 both 1. But and copper solid activity, this side is 1. This side is less than 1. So I write activity of copper is less than 1. By who? By what? Along according to this line. According to this line, which is when this will happen, which is smaller? Which is smaller? Less than 1. This 1 is less than 1. So this line will be stable line. The one which will refer to, which will result in activity, which refer to an activity, which is smaller activity, smaller of these two. Which is smaller of these two? So this is stable curve. This is stable curve. Because, right, reason? Right here also, stable curve. The one that gives rise to a lower activity, stable curve, and the one that gives rise to a higher activity is metastable curve. You see, this observation is in perfect agreement with your previous discussion. A moment ago we discussed and found out that these dotted lines are metastable, and here also you see this one activity of copper is 1 is greater, metastable. So this is metastable according to this discussion, this activity concept. Or activity means greater means free energy greater, and free energy greater and free energy smaller. Smaller one will be thus stable. So this one stable. So this is the discussion, nothing else. Okay. This discussion. So you write once more. This is right. This one you write. This is this right. Right here stable. Stable curve I have written here, and here you write also. This is metastable. Remember, which is greater activity or which is smaller activity? One is here greater than less than 1. I think this is understood. So once you are convinced, what I'll do to have the final diagram, tell me dotted lines are being metastable, out, what you will get? Out, okay? So this is this out. So you will have this diagram A, B, C, D, the one that I have already drawn. This I have drawn already. Okay? This is stable lines only I have drawn. So okay. So next one you will consider this is stable line, I tell you. This is stable line already established, BD. Then next you will get again 3-1. Then you can form this stable, metastable, then next will be metastable. And still next will be stable. Still next metastable. Alternately added. Okay. So can I remove this? Okay. This part is discussed nicely. So later, as I told you, I will take up D. 1D. Remove this. 1D. So this is a good discussion. Two different ways you will actually identify stable, metastable. And this was discussed last day. I repeated though, but it might be helpful. Okay, to repeat it. You could repeat good things, valuable things, no harm. So I start next D. D, as I told you, these three are over. D, I may consider this and this line, in fact. This line, CO2s and CUS, as I consider. So I will show you actually the slope and then I will draw. Then I will name them. Okay. So, but CO2s, CUS and gas phase. Quickly do this. D. Okay, very good. So I write the equilibrium first. Okay. What you write? CO2s, this is CO2 sulfur, S2. So we have used sulfur in that side. So write this way, it is better. CuS solid plus O2 gas is Cu2S solid plus SO2. Happy this I wrote. Let us balance this. This is what? Cu, this is Cu2. So 2 CuS, 2 sulfur, this 2 sulfur, 2S, balance, O2 is okay. So this is the relation number 4. D for this for 4. So move on. Delta G0 is A plus Bt. Delta G0 what? 4. A plus Bt. AB known is minus RT ln KT. ln KT. Or this gives you, all being known or accepting K, T is known means found is nothing but activity of Cu2S. Let me check. Cu2S solid times PSO2 over ACUS squared times PO2. This is pure solid. Pure solid is 1. Pure solid is 1. Pure solid means they are not forming solid solution. So pure 1 is what you have PSO2 by PO2. Should I write this? I should write PSO2. Clear now. Clear expression and take log as usual, or you write here, or log PSO2 is log PO2 plus log KT. Okay, then it is a straight line equation, linear equation. Acha, right here. Linear equation. So you should note that. Hence as you write like this. This part is will be like this. Hence the etc. And note as before like this. Okay, so repeated. How many total coming? 11 lines. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are into the fourth. D means fourth. So 7 are still coming. So be careful. So thank you. Or what? Hence, and like this, the log PSO2 versus log PO2 plot will be a straight line with the slope of what? How it is slope? Tell me. Y is x, mx, m is 1. Log P2, mx, m, slope of 1. Okay, good. Of 1, slope of 1 with the slope of 1 represented by, like exactly this. Repeat these lines and these lines. Okay, represented by line. Which line? Tell me. Which line you have? Cu2S and Cus by EG line. By line EG. By line EG. So along the line again. Next right. Along the line here. Along the line means line EG. Along the line EG. solid Cu2s solids Cu2s and the solids Cu2s and Cus coexist above the line, below the line, along above the line and Cus. Easy to follow that more sulfur potential. Cu2s and Cus is Cu2SO2. If you common make copper common, Cu2S2. So more sulfur potential. So PSO2 increases. So above will be Cus. Or here directly here, if we increase SO2, move to this, Cus will be stable. So above, if we increase this, above the line is Cus. So above the line, Cus solid, and below the line Cu2s solid are stable. Stable is okay. So Cu2 is stable. So this part is over. Let us take up another one, next one. Let us complete as many as possible. 4 down, still 7 to go. So E. Which one I will consider? Cu2s, Cu2O. Next we will consider Cu2s. Oh, sorry, I'm sorry. Cu2s, Cus is discussed means line EG discussed. Next we will consider Cu2s and CuSO4. Follow this. CuSO4 here. CuSO4 actually I have written many things here. CuSO4. Okay, I think you can read this, na? It's okay. CuSO4. So Cu2s and CuSO4. So write that. Gas space. Okay, happy? So E is what? Gas space. So you just complete the reaction. Cu2s solid plus SO2 gas plus O2 gas is copper sulfur, Cu sulfur solid is 2, the Cu2s 2, the 2 sulfur, you may have to make it 2 sulfur, okay, 8O, how many O's so far? 4, you need 8O, 4, okay. I made a mistake. I'm sorry. I made a mistake. Sulfur is already without 2 SO2. Without 2 of here it is already balanced. S1 and 1S. This is S. So 2S already taken care of. So 8 oxygen. Right hand side. How many oxygen? 2 here. 2 here. Because sulfur is already balanced. So don't touch this. 2. Don't touch 2. 6 oxygen remaining. CO2. So what is right? What you write? Delta G0. Quality equation what? Tell me equation 4, 5. Equation 5. Delta G0 5 is again A plus BT. Remember? A plus BT. A and B known. Is minus RT ln KT. Everything is known, so KT is known. Known means this expression for equilibrium constant activity of CuSO4 squared by activity of Cu2s solid. You may write here solid, so you will understand this pure solids. PSO2 times PO2 cubed. Happy? So what is the next job? Say that this is 1, this is 1. So what you have? Right? No, remove these lines. Remove these lines. Or you write here is what? 1 by PSO2 times PO2 cubed. So what does it mean? Or how many times?
2 hours gone.
None.
2 hours 15 seconds.
15 seconds. So 2 to 3 minutes. 3 minutes. 2 to 3 minutes. Or take log as before, or log PSO2 is what? If you follow this carefully, it will go to this side. Okay, PSO2 is minus, you think, minus 3 log PO2 minus log KT. Okay, minus log KT. Again, this is a linear equation. Linear. What is the slope? What is the slope? Log PSO2, log PO2, y, x, slope is minus 3. So that we mention again like this. Hence the log PSO2 versus log PO2. If we keep on writing, plot will be a straight line. Straight line with the slope of what slope? Minus 3, represented by line which line? Tell me, please tell me. These two CO2S, CS, which line? No, what I am discussing, I'm very sorry. CO2S and copper sulfate. CO2S and copper sulfate. CO2S, copper sulfate means this line. CO2S, copper sulfate. Bring copper here. Copper sulfate, CO2S, line ED. So represented by line ED. Represented by line ED. Okay. So will be a straight line. Okay. By line ED is okay. Then next is what you write? Along the line, above the line, below the line. Like this. Along the line ED. So you have write ED. This is the line that is generated now. ED. I show it. E. Along the line, both. Along the line, which will be? Tell me. Along the line and below the line. Along the line, right? Along line ED. Solids. Which solids? Tell me. Solids are what? CO2S. CO2S and CuSO4 coexist again along line coexist along line coexist colon. This should be colon here. This should be colon. Above the colon, above the line. Above the line, coexist. Above the line, what? Here, see, above the line, above copper sulfate. Above the line, here follow. Above the line, copper sulfate solid, and below the line, below is CO2S. CO2S, the other one. CO2S. solid below the line CO2s are stable. Why this happens? Actually, I tell you, as you increase the, see, you can follow this. If you increase SO2, for example, SO2 if you increase equilibrium, SO2 you increase, up, above which SO2 increases, giving you copper sulfate. So if you increase up, from this line up, copper sulfate. Or say oxygen if you increase x-axis, oxygen you increase means to the right copper sulfate. And when you decrease them, they will move to the left and CO2s will be stable. This one, to this. Up, above CuSO4, below CO2. So all these are stable. So with this actually, we have completed E5 down, 6 more to come. Next class we will take up 8. I am writing you next class. 8 will be what? Which line I tell you? E8. This is done. EG done, ED done, EF. Then we will be able to consider the triple point E next class. So EF will be next class as well. Let me write this. Next class is for which equilibrium? It is CuS and CuSO4. CuSO4 and gas phase. That will corresponds to line EF. Achha, next class, right? Next class. Happy? CuS, which is CuSO4 gas phase. So with this, today we have completed our class. We have finished our class, and thank you very much for your interest, energy, and your sincerity and your interest and your cooperation and all such things. Okay, so thank you very much. Okay, I hope you have understood how these stable metastable lines are distinguished, etc. So see you actually next class with this section F. Okay, this what is this? This is actually the with this point or with this division F. Okay, with this part F will start and 5 over, so 6 will come. Okay, we will actually have 6 more lines we'll discuss. Thank you. See you next class. Bye.